In this TEDx presentation from 11 years ago in Brussels, Jacques Vallee makes an amazing point. He really just kind of punches through all of the problems here, points it out. Physics needs to confront its demon. And its demon is the other half of the equation that it's ignoring. Chris Lado, welcome to Lado Files. This article from Particle Physics, A Deepening Crisis Forces Physicists to Rethink Structure of Nature's Laws, highlights the issues. For 3 decades, researchers hunted in vain for new elementary particles that would have explained why nature looks the way it does. As physicists confront that failure, they're re-examining a long-standing assumption that big stuff consists of smaller stuff. Look at that. The point here, it's a deepening crisis, and it's been going on for several decades, and it's not just in cosmology, it's a deepening crisis in physics, and it's not just in particle physics, it goes all the way up to cosmology.
In case you weren't aware, there is a crisis in cosmology right now, and I use the term crisis very loosely there. Essentially, we have 2 main methods for working out the rate that the universe is expanding at. And over the past couple of decades, as instruments and techniques for doing that have gotten better and better, those measurements have got more and more accurate. But
that is a big but from Dr. Becky. So what she shows in this video, excellent video, by the way, is that the expansion rate of the universe has some big problems. So first, this is the model, basically. So this is the year on the bottom here. You have 2000, up to about 2007, everything looked good. Okay, so this is the cosmic microwave background. Okay, that model you see here, CMB, cosmic microwave background. And this is the distance ladder, okay? How far away something is based on supernovas, basically spinning stars, Cepheid variables, type 1a supernovas, which I mentioned before. If there's an issue with your distance measurement of your supernovas, then all of your distance measuring goes out the window, right? Well, the problem is what they're finding is our current measurements based on the JWST, the James Webb Space Telescope, based on that, it doesn't match either one of these models, neither one. So basically what we've measured with the James Webb Space Telescope doesn't follow either one of these options. Okay, so basically both models are incorrect. Okay, so either your Cepheid variables, your type 1a supernovas don't tell you how far away something is, which is what I've kind of postulated in the past. I've said it on this channel. Or the cosmic microwave background, okay? That doesn't tell you why or how fast the universe is expanding. Okay, you're not getting the correct numbers. Okay, so our models, our current models for cosmology do not fit. Okay, so our views of the large part of the universe, how the actual universe is made, everything, are wrong, basically very wrong. And our models for the very small are also wrong. I'll show you after this. And there's many other things, any other issues with cosmology. I follow Anton Petrov. He's a popular YouTuber. He does many different videos, and it seems every day he has almost a new video on James Webb Space Telescope changing the game or some other breakthrough. Basically, the light that we're seeing out there is double the intensity of light that we should be seeing. We found phosphine gas on Venus, evidence of possibility of life. Galactic structures seem to be organized into streams. There's streams of actual galactic stars and gas and dust flowing around. Our general view of how large galaxies can be, stars, planets, pretty much all of our views on the actual greater universe are incorrect and being shown to be incorrect with these measurements from science systems like the James Webb Space Telescope, and showing here from Anton Petrov. That just shows that you can follow him to see that we are seeing breakthroughs pointing out all the things that we have wrong in our models, which is okay, right? You'll see the nerds such as Dr. Becky and all of her friends are very excited about these things. They're excited about it, but it should be noted that we don't know what is out there, okay? We really don't know what's going on, and our models are incorrect. It's not just our models of cosmology. It goes back to really the basics, fundamental basics, and we have a huge blind spot in our physics. And how did I see this? I felt it. But who pointed it out, I thought so beautifully, was Jacques Vallee in a TEDx presentation. Physics needs to confront its demon. and its demon is the other half of the equation that it's ignoring. I'll tell you the other half of that equation. Hopefully change your paradigm in this video. Thanks for being here. Smash that like button if you do like this content. Subscribe for future notifications, and then support the channel at patreon.com/Chris Lado. Let's get to the video.
A theory of everything else. Physicists today, professional physicists, are developing various theories of everything to try to reconcile the two major successful theories of physics today, general relativity and quantum mechanics. There are a couple of dirty little secrets in there that they are not telling you. The first one is that these two theories, each of which works very well in its own domain, are in violent contradiction in most of our world every day.
If you don't know, Jacques Vallee is probably the most famous UFOlogist. Okay, he is the Jacques Cousteau of UFOs. Okay, and he's still able to maintain his credibility after so many years. His first point here is there is some dirty, dirty secrets. Okay, he was trained as a physicist. The dirty secrets he relays is that the first point is that general relativity, which is what Einstein created, and quantum mechanics, okay, that system, modern system, the standard model of quantum mechanics, he says the first dirty secret is that not only do they not agree, but they are in violent opposition. Okay, you can't have both things. You can't have general relativity and our current understanding of quantum mechanics because they simply are in violent opposition, is what he says, okay?
Especially with gravity. Therefore, the idea is to try to develop theories of everything that would reconcile somehow, like string theory and others, would reconcile these two dominant views of physics. The other dirty little secret is that in all that, we have left out a missing child. The missing child is the little sister of physics, is the physics of information, and that's what I would like to talk about this afternoon.
Boom, and that's it. He says it in that kind of monotone delivery, but man, that is really, it's really groundbreaking. Okay, so what I'm considering is a yin and a yang. Okay, you have the whole idea for what the answer is to physics, and right now we're only looking at half the problem. Okay, and he argues we're only looking at the physics of energy. We're only looking at the physics of energy. And what we're missing is the lost child of physics. What he calls here the missing child that would put everything together as the other half of the equation is the physics of information. The physics of information.
The physics they teach us in college and in universities is the physics of energy. It has to do with lasers and colors and particles and mass and fields, whatever a field is, and acceleration and inertia and all these things that you've been exposed to in high school or college and university. The problem is that they also teach us that information and energy are two sides of the same coin, but they never bothered to teach us the physics of information. They continue to teach us the physics of energy. Now, going back to the 19th century, James Maxwell, discussing thermodynamics, took a very simple idea that if you pour hot liquid into a cold liquid, there will be an average temperature of the liquid between these two components. The only way to stop that would be for a little demon, Maxwell's demon, to be there and to separate these molecules. But absent this demon, the law of thermodynamics will say the two liquids will mix and will reach an average tepid temperature. Leo Szilard, who was a colleague of Einstein in 1929, went one step further and said for the demon to be able to do this, the demon needs information about which molecules are hot and which molecules are cold. If the demon knows that, then the demon can, in fact, keep the two liquids separated and they will never reach an average temperature. But that means that there is just as much information as there is energy in the system, and that information and energy are, in fact, the two sides of the same coin.
Okay, that's it. That's Maxwell's demon. Okay, Maxwell's demon talks about entropy. Basically is entropy. If you pour hot water and cold water into the same glass, thermodynamically, they will interact. The energy will spread out of the system. The energy will disperse. The entropy will disperse. The disorder will increase till the whole system is boring and the same thing, monotonous, okay? Except you and me, right now, communicating somehow through these devices, these systems, telepathically. How is that happening? Okay, at some point, life had to reverse this, or something had to reverse this, and life came out. Okay, this is the idea of Maxwell's demon. This idea is explained very well by PBS, Physics of Space Time. I'm going to play you a short clip here explaining Maxwell's demon.
Well, actually, it turns out that even these specific high entropy configurations can be transformed to low entropy as long as we have information about the state. To understand this, you're finally going to have to meet Maxwell's demon. As well as unifying the equations of electromagnetism, James Clerk Maxwell was one of the founders of statistical mechanics. Understanding that entropy was a statistical phenomenon, he came up with a thought experiment to explore just how fundamental the second law of thermodynamics really was. He imagined a box with two halves, sealed by a wall between them. The wall has a tiny door, large enough for a single molecule to pass through. The air throughout the box is the same temperature, so even if we open the door, temperature would stay the same. The halves are in thermal equilibrium with each other, and if the box is isolated from its surroundings, then this is the state of maximum entropy. Let's introduce the demon. The demon has the ability to observe the speed and trajectories of individual particles in the system. It can also open and close the door between the sides. Every time the demon sees a high-speed particle approaching from the right, it opens the door to let it pass to the left side, and it lets low-speed particles pass left to right. Soon enough, the left side is full of fast particles and is hot, while the right contains slow particles and is cold.
This is Maxwell's demon. So you see, he was able to open the door, right, and let in the hot particles to the left side or the cold particles to the right side. Either way, provided order. Okay, Maxwell's demon did something to the system, made it more ordered. That required information. So he had to have information on which particles were hot or cold. This is what life does. We organize across energy gradients. Life orders across energy gradients. That's what life does. Maxwell's demon. But they explain it away, right? They always have an answer. Theoretical physics, right? They can never say, well, we just sure don't know, because they always have an answer for this, right? Because this would mean that information and energy are essentially into the system. Not only do you have energy, you also have information. But all of our physics constants, all of our physics models only look at the energy side of it, the energy side of the equation. They're missing the other half of the yin and the yang.
We are no longer in thermal equilibrium, and the entropy is lower than before the demon started. This temperature differential can then be used to drive a heat engine and do work. But all of this appears to have been done without exchanging energy or entropy with the outside universe. This seems to violate the second law of thermodynamics, which demands entropy remain constant or increase unless energy is exchanged with the outside universe.
This is what life does. Life actually orders the system to create an energy gradient, and then it uses that energy gradient to do work. That is how we actually organize. That's how life actually works. Even at the base smallest level, Michael Levin, he argues that across an actual cell, that's actually how the mitochondria even makes energy, okay, is that there is a gradient, specifically a gradient across ATP at the very microscopic level. How your cells even make energy is an actual electrochemical gradient across a simple cell. That's how they actually burn calories. It's electrochemical gradient. Okay, so this is what life does. Isn't Maxwell's demon proof of life? Wow, they always have an answer, don't they? Let's see.
But it turns out there's one last step in the process of sorting particles where the increase of entropy is unavoidable. Weirdly, it's not in the measurement of particle trajectories or the motion of the door. It's in the storage of information. It's in the memory of the demon. See, in order for the demon to do its job, it must learn about the particles. The demon, or the particle sorting system it represents, must start in some known predictable state, which is altered by interaction with a particle into some unknown state. From our point of view, the randomness of the particles decreases, but that randomness is transferred to the memory of the demon. But even demons have finite memory. At some point, the system for sorting particles needs to be reset to continue its work. To erase the information of past sorting means to transform some arbitrarily jumbled state into a single known state. That's a physical process that reduces the demon's internal entropy, and that takes an irreversible transfer of energy. The demon has to radiate heat, which means transferring entropy back into the box or to the universe. Either way, the second law is preserved. This resolution was proposed by Rolf Landauer in 1960, nearly 100 years after Maxwell proposed the conundrum. Both Maxwell's conundrum and Landauer's resolution are fascinating because they highlight the fundamental link between entropy and information. Firstly, they show that information about a system allows us to extract useful work. If you have perfect knowledge of the state of all particles in the box, you could open and close the door in exactly the right sequence to sort the particles any way you liked. You could turn any perfectly known equilibrium state into literally any other non-equilibrium state.
So that is their explanation, right? The explanation solving Maxwell's demon is that Maxwell's demon has to write the information down somewhere. And by writing it down, he'll have to destroy it at some point, because he can't have infinite memory. So by destroying it, he'll have to destroy the information, and that's how we raise the entropy. That's how they can't say that the entropy just goes away. Make up something else. I think they're still missing a big part of the equation. Okay, before we continue with the second dirty secret, let's go back to the first here. Okay, Jacques Vallee says that quantum mechanics is not compatible with general relativity, and he says actually they're in violent opposition. And really, why is this? Okay, what is the problem? Okay, let's read here. So, in general relativity, events are continuous and deterministic, meaning that every cause matches up to a specific local effect. Okay, so general relativity. I push you this way, you are going to go that way. Okay, a body already in motion is not going to change unless affected by another force. Okay, this is kind of the idea, cause and effect. I push here, that happened. There's everything can be mapped out. If we have the actual understanding of the universe, the quantum states of everything, then we can perfectly dictate what's going to happen in the future. Okay, the universe is deterministic. It's all based on cause and effect. I tell you this, you go and do something else. Okay, that is general relativity's understanding of the universe. This is in violent opposition to quantum mechanics. Okay, in quantum mechanics, that's not the case. Events produced by the interaction of subatomic particles happen in jumps, quantum jumps, with probabilistic rather than definite outcomes. This means it's all probabilistic. Okay, when you search using general relativity mindset and you go down, down, smaller and smaller and smaller, trying to find the base elementary particle, right? What's the particle? What's the boson that's going to pass all that information, right? That's going to push this, that's going to push that. What they're finding is there's nothing there. There's nothing there to see. It's all probabilistic. It's all fields. It's all just relational things. Perspective. Change. You're seeing change in states. They're actually not seeing any natural fundamental particles. That's what they're learning. It's basically based on information. Okay, our quantum mechanics are very, very, very accurate in dictating, but they are in violent opposition to our general relativistic understanding of the universe. Okay, this is a very large crisis that they're not highlighting. Okay, and that's the dirty secret. Jacques Vallee says is that not only do they not friendly with each other, they're actually in violent opposition. And really, he says it's about gravity, because they can't find gravity in quantum mechanics. Gravity doesn't come out of anything. But in general relativity, man, there sure is a lot of gravity around here, isn't it? And we still don't know what it is. It's not a force. Interesting. So if we go back to Jacques Vallee here, here's this half of physics that we're studying right now. Particles, atoms, fundamental forces, mass, entropy, fields, space, dimensions, okay? Time. He has a big argument here against time. He argues time is not another dimension. How could it be another dimension? 30 seconds on why time is, I don't think, is necessarily a dimension is we have 3 dimensions right now, right? If we take away one of these dimensions, one of the space dimensions, we go down to 2 dimensions, we still could have life, right? You think of flat land, think of that. There is motion, energy gradients. You have Maxwell's demon, even able to act in there. You could even go down to 1. So take away that second dimension, go down to 1 dimension. We still have time. But now you take away time, okay? Imagine there's no time in our current universe. Now it's just a picture. There's no energy transfer, right? Because there's no change. There's no entropy, right? Because there's no change. And there's no gravity, right? Because you can't tell if anything's going towards anything else, right? Maybe it's actually there, but you're not actually going to be able to detect it. Gravity will fall out of your equation, not going to be there. Remove time, and energy transfer isn't possible, entropy isn't possible, and life isn't possible. Never mind gravity. Think about that. We get back to it. Momentum, inertia, speed, and quanta. These are the physics of energy. What is the physics of information? That's the rest of this briefing, okay? The physics of information.
So where is the missing sister of physics? The physics of energy has to do, again, with particles and atoms and fundamental forces and mass and entropy and fields and space dimensions, x, y, and z, and t for time, and momentum and inertia and speed and so on. But we never talk about similar concepts on the side of the physics of information. And my argument is that in the next 50 years, we will.
And I think we will. It's been 11 years since this TED Talk, and we haven't had any major breakthroughs. In fact, the things that Jacques Vallee is saying here are actually just more true now. So what is the physics of information? He talks about it. He says idiosyncrasies, those synchronicities. He relays a couple synchronicities that he just couldn't explain. There are these things out there, these outliers of life, outliers of the universe. There's the gotcha is, how can life exist if the second law of thermodynamics is true? And I agree with Jacques. I think the next 10 years is going to be about the physics of information, the other half of the yin and the yang that we aren't considering. So what are the constants or terms of the physics of information? And it seems like we still don't know. He mentioned some synchronicities. He says there's synchronicities to life that we simply can't explain. My personal viewpoint is we focus on life. Focus on Maxwell's demon. Is life Maxwell's demon? And where is the information? Where is this memory that they say exists in the system, the demon's memory? Where is this actual memory? Is that DNA? This last thought is basically life is Maxwell's demon. It lives on these energy gradients. And it organizes based on information. Life is able to get energy to create work out of a system by knowing the information across these energy gradients. Has to be an energy gradient though. Watch here, PBS Space Time explains it. Amazing.
Another way to say this is that life feeds on energy gradients. When two systems with very different energy densities come into contact, energy must flow. Life feeds on that flow. In fact, the importance of energy gradients to life can help us understand the actual origin of life and its precursors.
So life needs an energy gradient. It needs a hot and a cold next to each other so it can open the little door. So it can get work out of the system. So we could be looking for places in the universe that have energy gradients. We can almost expect there to be life. We can almost expect it.
These systems are doing their best to obey the second law of thermodynamics by redistributing their energy as evenly and randomly as they can. Heat energy flows from hot to cold, seeking a uniform temperature. But energy is also dispersed into every form it can take, consistent with the laws of physics. Energy is perfectly evenly distributed, and new molecules break apart exactly as often as they're formed. But when our energy source is flowing into a much larger reservoir, like the ocean for example, then equilibrium is never reached. Complexity can increase indefinitely as a byproduct of the system striving to redistribute the endless gradient in energy. And at some point, natural selection takes over. Molecules self-catalyze. They help drive the very reactions that create more of the same. Molecules better at that process become more abundant, and at some point they become true self-replicators.
So could life be the information side of physics? Is that what we're missing? Information passed through DNA. Other ways to pass information. What is the physics of information? Thanks to Jacques Vallee. Man, he's opening our eyes. So 11 years later, physics has more problems than when it did in 2011. Most of the questions have not been answered. And the more we find, the more we learn we don't know. But this is great, right? The nerds of the world should be happy. I'm happy. There's so much more we can learn, but we do need to consider other paradigms, other models. Looking back in history, we're always proven wrong, right? There's always a new, more accurate model. It's usually simpler, it's usually grander, and we're usually not right at the center. But for this one, maybe you are. Maybe life is the physics of information if we can solve Maxwell's demon. Maybe there's nothing to solve. My own view is entropy is like gravity. If you look at gravity, it's just the shape of our actual space-time. It's the shape of the universe. If we take away time, we have none of these things, right? We do have no energy transfer. There may be gradients, but nothing will transfer. You cannot have life without time. And this goes into the possible why of life. The possible why of life here. PBS Space Time again. Watch this.
They become true self-replicators, and eventually they become life. But even life and self-replication might be a very natural part of the same thermodynamic drive to dissipate energy. I mean, think about it. Living things are incredible heat dissipation, entropy maximizing machines. The most random possible form for energy is thermal radiation, and the lower the energy of its component photons, the higher the entropy. A plant absorbs the concentrated ultraviolet light from the sun and reprocesses it into a much higher entropy infrared heat glow.
So look at that. This may be actually why life is here. The actual purpose of life to act as a cooling mechanism. I think of it as a yin and the yang of the universe. You basically have the hot energy, basically the driver of these gradients. But you have life that lives along these gradients, comes about because of it, but ultimately cools the system. Okay, cools it, acts as the radiator, basically, of this, whatever it is, life process that you and I are experiencing right now. John Lovelock, he was the writer of Gaia, the Gaia hypothesis. This was actually his viewpoint as well, is that life in the future will be kept around. Even if we get super smart AI, they will still keep organic life like you and me around because we cool the planet. We provide a cooling mechanism because overheating, entropy or heat death is the worst part of the universe, I guess. And that's what life does. We actually cool it down, increase complexity for some reason or other. Okay, so anyway, very exciting video. I love this. I love the fact that all of this information is out there for free on YouTube. Thank you so much to all these other YouTubers out there. Thanks for publishing. Thanks for sharing. And you, thanks for being here. Thanks for watching. What do you think? Let me know in the comments. I try and read all the comments. I do mostly UAP videos, but I think this theory is intimately related, somehow related. And then finally, if you want to get exclusive videos, go to patreon.com/Chris Lato. I post exclusive backstage content on there. Support the team. It's only $5 a month, and you get no ads to all these videos. And as always, UAP Society, you can get merch. That helps us as well, or come join us on our Discord. Thanks again to all my patrons. Thanks again for being here. Have a great day. Peace.